days, last week, we were doing polynomial functions. That's when they were y equals. And then on Friday, we started polynomial equations. That's when we took our polynomial, set it equal to 0. So we're looking for solutions. And remember, we learned on Friday that we can take each part of the equation, set it equal to 0, and solve it. So if I take this first piece and set that equal to 0, that's 3x minus 7 equals 0. I'm just going to solve it for x. So I'm going to add 7 to both sides. And then divide by 3. So I get my first solution is x equals 7/3. But that's just one solution. If I look at this equation, how many solutions should I have? Really?
You should have 3.
I should have 3. 1 for this linear piece and 2 for this quadratic piece. Whatever your degree is when it's in standard form, which if I multiplied this all out, it would be cubic, I should have 3 solutions. So I only found one of them. I found x equals 7/3. So now I need to find the solutions for this piece. There's a lot of different ways that you can find the solutions to a quadratic, but for this particular assignment, they want us to use the quadratic formula. It says right up here at the top. So there it is. But before we launch into using the quadratic formula, I want to make sure that all of you know how to simplify a radical. Because down at the bottom, these are not decimal answers. We are not plugging this in and getting a decimal for a solution. We have simplified radical answers. Because mathematicians like simplified radicals, we hate decimals. So I'm going to remind you how to simplify a radical, or teach for the first time if you don't know. So let's say I have square root 48. First thing you always want to ask yourself is it a perfect square? Is 48 a perfect square?
It was 7. 7 times 7.
That's 49.
That's 49.
So close, man.
You were close. You were close. If you do not know your perfect squares, at least up to 13, you need to memorize them. Because there's going to be lots of situations where you need to know them. You also probably need to know that 15 squared is 225 and 25 squared is 625. It's not a perfect square, so instead I need to break it down. I'm going to show you my way. If you already know how to do this and you're very good at it, there's a couple of different ways to do it. Then do your way. As long as you're getting right answers, it's fine with me, but for the purposes of teaching, I'm going to teach it my way. So I'm going to use a prime factorization tree. So I'm going to pick any 2 factors of the number that I can think of, and I'm just going to use 6 and 8 this time. And I'm going to factor it all the way down to prime factors. That means numbers that are divisible by only themselves and 1, which 6 and 8 are not prime. 6 is divisible by 2, so that'd be 2 and 3. And 8 is also divisible by 2, that'd be 2 and 4. 2 is prime, 3 is prime, 2 is prime, but 4 is not. It can be divided by 2 and 2. Okay, there is a reason why I mark out the branch above it, because I don't want to cause myself confusion later. See, there is no longer an 8 anymore. 8 has now been broken down into 2 times 2 times 2. Because 2 times 2 times 2 is 8. So that's why I marked them out, and because of this next thing. So the whole point here is for me to figure out what my radical actually equals. So it's a square root. That's an index of 2, because it's the opposite of squaring, which is an exponent of 2. That's an index of 2, which means I'm grouping in groups of 2. 2 matching numbers. And I happen to have 2 matching numbers right here. 2 2s. And 2 2s right here. That's 2 groups. But I have this poor little guy by himself right here. Oh, poor loner. He's very lonely. Lonely people stay at home in the house by themselves. The 3 goes in the house because he's alone. If you're with a group of people, you go out with your group of friends. So I have 2 groups. 2 times 2 on the outside, that would be 4 square root 3. Got it, sort of? Let's do another one. Let's do square root of 108.
Yes.
All right. So I need 2 factors of 108. If y'all are like me, I'm off the top of my head, I don't know 2 factors except for it ends in an 8, which means that it's even. That one works too. So 9 and 12, 4 and 27, 2 and 54. Doesn't matter. Start wherever you want. You're going to get the same thing no matter where you start. So I'm going to go, let's go 9. I'm going to go 9 and 12. You just start wherever you want. Remember, we're going all the way down to prime factors. Now, it doesn't matter what factors you started with. You should end up with 3, 3, 3, 2, and 2. Maybe not in that order, but you at least have those. You are grouping in groups of 2 because this is a square root. So I have 2 matching 2s and 2 matching 3s. Loner stays by himself at home. He is very lonely in the house. Number groups go out. A 3 goes out and a 2 goes out. That gives me 6 square root 3. Everybody okay? All right, you want to do one by yourself? Let's do one by yourself. How about square root of 180? All right, so I got 2, 3, 3, 2, 5, doesn't matter what order. I got a group of 3s and a group of 2s and a poor little loner 5 stays at home. So it is 6 square root 5.
Where are you getting that number now?
The groups, you multiply them. So there's a group of 2s and a group of 3s. 2 times 3 is 6. Y'all okay? Yeah?
That's not equal 6.
Y'all want to try one more?
Sure.
Square root 60. You do?
Yeah, I was about to say where first Q and
What the?
Maybe I have no square root.
All right, so when I broke it all the way down, I used 2 and 30. You could use 20 and 3. You could use 6 and 10. You could use 15 and 4. So I used 2 and 30, and I got 2, 2, 3, and 5. So there's a group of 2s. Groups going out. These are both. You cannot group these together. They are not friends because they're not the same. That's very judgmental of them, but they are not friends. But they're both staying at home, so you're going to multiply back underneath, so it'd be 15 underneath and 2 on the outside. So it's 2 square root 15. So are we good for the most part? All right. Okay, so back to using the quadratic formula. So the quadratic formula is on the top of the page. If you don't have it memorized, you need to memorize it because it is one of the only formulas that is never given to you on any, so whenever they do like the SAT, ACT, most of the time they're pretty nice about giving you formulas in the problem. Like if they ask you to find surface area of a sphere, they're going to give you the formula for surface area of a sphere. They will never give you the quadratic formula because they think you should know it. They also won't ever give you Pythagorean theorem because you should know that one too. So you need to memorize it. So there's a little song. It goes like this. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. I will sing it every time. I'll sing it every time till you know it. So we need to plug into the quadratic formula. There's not a whole lot of room in this box, and so that you guys can see what I'm doing, I'm going to do it on another page just because I don't think there's enough room in that little box. So I am plugging in, this is my quadratic, the 6x squared minus 7x minus 20. I am plugging it into the quadratic formula. So the quadratic formula is negative b. Well, my b is already negative. It's negative 7. So I'm plugging in negative 7 plus or minus the square root of b squared, so that's negative 7 squared, minus 4ac, so that's 6 times negative 20, all over 2a, so that's 2 times 6. All right, from here, I am just simplifying. Now, you can't just plug the whole thing in your calculator because calculator is going to give you a decimal answer, and I don't want decimal answers. I want simplified radicals. So I'm just going to simplify it myself. Negative 7 is positive 7, plus or minus. Negative 7 squared is positive 49. All day long, squaring a negative gives you a positive. Negative 4 times 6 times negative 20 is positive 480. 48 with a 0 on the end. All over 12. I'm just going to continue to simplify. 7 plus or minus 49 plus 480 is 529. All right, so right here is where I would break down 529. But before you ever start the breakdown, if you don't recognize it as being a perfect square, you might want to check it. Because square root of 529, somebody check it for me. See if it's a perfect square. 23. Yeah, it's the square root of 23. So that means that this is a perfect square, which means I don't need a radical anymore. I'm taking the square root and I'm getting 23. So I get 7 plus or minus 23 over 12. This is actually two separate problems. It'd be 7 plus 23 over 12 and 7 minus 23 over 12. That's 30 over 12, which simplifies. 6 goes into both of those, so it simplifies to 5 halves. And 7 minus 23 is negative 16 over 12. 4 goes into both of those, so it's negative 4/3. All right, so those are my other two solutions. So remember, we said we should have 3 solutions. So I should have x equals 5 halves and x equals negative 4/3. So down at the bottom, I should be able to find my solutions. So there's 5 halves, and negative 4/3 is right there, and positive 7/3 is right there. The letters should make a word. Now, if you're not good at word scrambles, just write the letters down. I don't care if you get them in the right order, but this one I got. I'm not good at word scrambles either, and I can't spell, so I'm terrible at it. But this one I got. Button.
I don't like it all that.
Okay, so now you go and solve the rest. It is due. So go.
I need to do the quiz because it's closed.
Okay.
Whoa, whoa, what?